Okay, so let's take a look at review on nth roots. So we've done square roots already in the last unit 1, part 1. And now we're going to do square roots, cubed roots and fourth roots, etc. Okay, so here's the properties of the roots. Again, everything that we're going to do, you've kind of seen already. One important thing is if you have the nth root of something to the nth power, they cancel each other out. So for instance, the cubed root, and then you raise it to the third power, that's just going to be whatever the number is inside. And that would be true for all of them. Also, when you're taking the nth root of everything inside, it's like taking the nth root of each individual part with a multiplication sign, because this is like saying x times y. So that does not change. All these rules are the same as the square roots, okay? So if you look to the right, these were already rules we went over with the square roots. The third one, even when you're dividing, you can break it up with the nth root, just like the square roots, we could break it up into two, the numerator and denominator. If n is even, we're going to assume that x is always going to be positive in this class. So the square root of x squared is just going to be, technically it's the absolute value, but we just say it's x. The square root and the square cancel each other out. So we always just assume it's positive. If n is odd, though, you could have a negative answer. So we know the square root of a negative number, so like the square root of negative 25, for instance, we know that's 5i. But if you're going to do the cubed root of, let me pick a perfect one, so negative 125, that ends up being negative 5. Why? Because negative 125 is negative 5 times negative 5 times negative 5. That's 3 negative 5s. And if you have this kind of overlapping root symbol, you can go ahead and do m times n and condense it into 1. Okay, so let's actually start doing the problems, because a lot of times for students it makes more sense when you actually do the problems. So not a lot, because again, this is review. So things you should know, and a lot of this is also listed on the very first page of your notes, a number. And when you're simplifying a square, you're looking for perfect squares. When you're simplifying a cube, you're looking for perfect cubes that fit into it with no fraction or decimal remaining. If it's a fourth, you're looking for perfect fourths. So let's go ahead and take a look from here. The cubed root of 54. So the cubed root of 54, I'm looking at one of these numbers that divide into 54. So I'm like, the largest one is 27. So I'm going to break that up into the cubed root of 27 times the cubed root of 2, because again, 27 times 2 is 54. And again, I want to pick one of those numbers I highlighted. The cubed root of 27 is 3, right? If you look directly above. So we've got 3 cubed root 2. Don't forget this little index, this number that is listed on like the diving board, I like to call it. You need to show that it's a cubed root. If you forget that number, then you're showing it's a square root. Okay, next one, 16y to the 5th. So now we're still doing a cube. So you're looking for the largest number that I highlighted above, 1, 8, etc. 8 goes into it. So 8 times 2, the cubed root of 8 is 2. So we simplified the 16, but what about the variables? With square roots, you saw that I looked for perfect pairs. So we have 5 y's. With cubed roots, you're looking for how many groups of 3. So I can pull out one group. So that would just be y to the first power, or just y. And notice there's 2 y's left over, so y squared is left inside. And that would be my answer. So for cubed roots, you're looking for groups of 3. Let's try some fourth roots. So for fourth roots, now we're focusing on these numbers here, fourth powers. So 32, I'm looking for 1, 16, 81. What goes into it? 16. 1 will always go into it, FYI. But then that means it won't simplify if it's the only one. So 16 times 2. And again, we're doing fourth roots. The fourth root of 16 we know is really 2. And then we also have a 2 stuck inside. For my variables, I have x to the 4th. I'm looking for groups of 4. That's one group. So 1x comes out. Y to the 9th. That's 1, 2. 2 groups come out. And this one has a y left over. So that's my full answer. Part D, 256. Oh, look at 256 is one of my numbers. The 4th root of 256 is 4. It works out magically. So 4 comes out. There's nothing left over. So now I'm just doing my variables. X to the 8th, and maybe you don't need to draw a picture. Hopefully you're at that point, is 2 groups. So x squared. Y to the 4th. Hopefully that's a pretty easy one, is 1 group. And you don't have any 4th roots left over. That happens sometimes. Okay, so let's just review with negatives. The square root of negative 128 is going to be an imaginary number. So the square root of a negative is imaginary. So 128 breaks up into, you could say, the square root of 64 times the square root of 2. Square root of 64, we've got 8i. And the 2 stays in. The cubed root of a negative is going to be a negative. And you can find that on your calculator. Math. Option 4 is a cubed root. And if you type in the cubed root of negative 128, it says it's negative 5.03, blah, blah, blah. It is a negative number. But again, we want the exact answer. But for a cubed root of negative 128, I'm looking at my perfect cubes that fit in. So 128, 64 goes in there as well, but the cubed of 64. But since we're doing the cubed root of negative 64, it's negative 4. Don't think square root of 64 is 8. We're doing the cubed root, which is 4, negative 4. And then we still have that 2 inside. So two very different answers. You should be able to do both of these. We won't be doing 4th roots of negative numbers. That cannot happen. So you don't have to really worry about that. But you do need to know the difference between the negatives if it's a square root or if it's going to be a cubed root. Okay, so that is it for our notes today.